Today we have to start a very simple problems, and then how the people understanding response is there, then it depends, then we can increase the level of understanding. Is there any question when I'm teaching? You have any doubt or any question? You can chart the chat box and they have to inform me. Then I can understand. I will reply. Okay. Is it okay, madam?
Sir, yes, it is okay, sir.
Okay. The first I have to start with only the CSIR problem. Directly I have to solve the CSIR problem, and the problem how we have to approach means first we have to read the question paper and what are things they needed we have to collect, and then we try to solve it. That's all. Okay. If you want to understand, please you have to ask that short box. Then I can repeat it. Is it okay?
Yes, sir.
Okay, madam. The first I have to start the one problem today. So today, actually the plan is real analysis. 2 days we have to do the problems. 2 days for real analysis, remaining 2 days for algebra, then complex analysis, then OD or PD, whatever it may be. It depends. We will do it. Okay. Anyway, fine. So today course a real analysis solving problem session. Just I have to start the first basic problem. Problem number 1. Directly we do the problems. For alpha in R, let notation of alpha. Alpha is a greatest integer. Denote the greatest integer. Greatest integer. Greatest integer smaller than or just write the problem equal to alpha. Now they have to define D R cross R to 0 to infinity. By how they are defining D of x comma y equal to greatest integer of mod of x minus y. For x comma y in R, just I write it and I explain it, don't worry. Then which of the following are true? Which of the following are true? Just I write very shortly. Option A, D of x comma y equal to 0 if and only if x equal to y, where x comma y in R. I think this is the question paper CSIR. Forget, I think 2000 December or June, not sure, 2019. But anyway, this is a CSR question. D of x comma y equal to D of y comma x comma y in R. Option C, D of x comma y always less than or equal to D of x comma z plus D of z comma y. Every x, y, z in R. Last D option. D is not metric. D is not metric. D is not metric. D is not metric. Please write the question paper. Please write the question paper. So time is okay for you? Okay, anyway, we have to start the solve. We have to try to solve the problems. Something is zoom in, zoom out. Okay, those who written the question paper, please try to read individually. So what is the given question? Just read. For alpha in R, this is the notation for greatest integer notation. This is the notation for greatest integer. You know, right? Everyone know about greatest integer. What is that meaning? This notation denotes the greatest integer is smaller than equal to alpha. Greatest integer. Suppose there is a number k, greatest integer of k means we have to find a integer which are less than or equal to that number and which is integer. Okay, for example, 1.5. What is the greatest integer? 1. 2.5. What is the greatest integer? Just 2. Okay, like that meaning, right? Okay, anyway, fine. That is the given. So d going from r cross r to this. This is a d is a function. The function defined like this things. What is that? Just a given modulus of x minus y. They will take a greatest integer. Modulus of x minus y, then they will take a greatest integer. Then which are the following are true? Which are the following are true? The first option d of x comma y equal to 0 if and only if x equal to y. When x comma y belongs to R. What about second option? D of x comma y equal to d of y comma x for all x comma y. Third one, the triangle inequality d of x comma y always less than or equal to d of x comma z plus d of z comma y for every x comma y z in R. Fourth one, d is not metric. D is not a metric. So what is that meaning? The given the function, they have to define. They will be asking which are the following conditions satisfied. Which are the following conditions satisfied? What is your guess? What is your guess? If you know the answer, just you can chart the box. What is your guess? The thing is that suppose you have feel this is true now, you have to prove it. A, B, C. Okay, very good. Somebody's tried A, B, C. Good. But that is not a correct answer. We don't know. Just somebody's prove it. Okay, B, D. Very good. Good try. Come on. Come on. B, D. Very good. They are tried. We don't know whether it is correct or not. Still, we are not decided. But we are trying. Good. Somebody is BD. Very good. ABC. Very good. ABC. Okay, very good. Good. Come on. Good try. D only. Okay. But the answer is BD only. The correct answer is BD. Now we have to show it. The correct answer is BD only. The correct answer is BD only. How? How? How BD only? Okay, anyway, we will do it. First option wrong. It's a false. Why it is false? False means you have, what is this meaning? D of x comma y equal to 0 if and only if x equal to y. Whenever d of x comma y equal to 0, which implies x equal to y, if and only if. Suppose we have to feel it is a false first option, then you have to give an example. It means example means find x and y such that d of x comma y equal to 0, but x not equal to y. Okay. Solution A false. Just we have to give the reason. X equal to 1, y equal to half. D of x comma y, which is implies D of 1 comma 1 by 2. This is nothing but what is that meaning? Just mod of 1 minus 1 by 2, greatest integer. Mod of 1 minus 1 by 2, just 1 by 2. Is it correct? Modulus of 1 by 2 means just 1 by 2. So what is the greatest integer of mod of 1 by 2? Sorry, not mod, not necessarily. 1 by 2 is a positive number. Just you can take modulus, just itself only. So greatest integer of 1 by 2 is 0. Greatest integer of 1 by 2 is 0. So d of 1 comma 1 by 2 equal to 0, but x not equal to y. 1 not equal to 1 by 2. We know very clear, right? So what is that meaning? Suppose this option is true, d of x comma y equal to 0, which implies x equal to y, right? But what is the giving contradiction? X equal to 1 and y equal to 1 by 2, but d of 1 comma 1 by 2 equal to 0, but x not equal to y. Actually, suppose this is true means whenever d of x comma y equal to 0, which implies always x equal to y. But I have an element x equal to 1 and y equal to 1 by 2. When you substitute d of 1 comma 1 by 2 equal to 0, but x not equal to y. But therefore, this option is not always true. Are you okay? Please, if you understand, just give yes. Say the chat box. Are you okay? Come on. Okay. Okay. Actually, we are conducting for most probably for whatever I felt yesterday. Most of the Tamil students only they are attending. Then I was very comfortable with. We have to talk with our mother tongue. But today they have to inform. So other state people also they are attended. So that is why we are trying to talk within English. But anyway, whatever you understand, just you type the chat box. Otherwise, I can't understand whether you people understood or not. Okay. Anyway, fine. So what about the second option? What about second option? Second option B. D of x comma y equal to d of y comma x. So we have to show this is a true statement, means we have to prove it. Suppose you have to feel B option is true, you have to prove it. What is the definition of d of x comma y? D of x comma y equal to greatest integer of modulus of x minus y. What is this meaning? Modulus property, you know, right? Mod of x minus y equal to mod of y minus x for every x comma y in R, right? Okay. So according to that property, mod of y minus x, we can write. There is nothing make a problem. Then this is by definition d of y comma x. Is it okay? Is it okay? Are you okay? Just to see that. Just I take this left hand side d of x comma y, just apply the definition of d of x comma y. I applied and I can use that modulus property. Mod of x minus y equal to mod of y minus x. Just I replace it by definition d of y comma x. But this implies what is that? D of x comma y equal to d of y comma x for all x. Is it okay? Therefore, option B is always true. Option B is always true. What about C? What about C option? What about C? Also false statement. So once you feel false statement means, then you have to give the example. You have to give the example. You have to suitably. You have to choose the element x and y z. X and y z. So I have to choose x equal to 2 and y equal to 4, z equal to 3.5. Okay. D of x comma y. What is that? Greatest integer of modulus of 2 minus 4. This is equal to modulus of 2. Greatest integer of 2 is 2 only. One side. What about d of x comma z plus d of z comma y? Greatest integer of x minus 3 by 2, sorry, 3 by 2, 3.5. What is that x? X equal to 2, greatest integer plus greatest integer of 3.5 minus 4, Modulus of greatest integer. Just a substitute. This means 1.5. 1.5 means greatest integer value 1 plus this means half. Greatest integer of half means this is going to greatest integer of half. This is equal to 0, which implies 1. But what is that the option is saying like this? It says that 2 less than or equal to 1. This is not possible, right? Because this side the value is 2, this side is 1. This is not true. So which means not true for all x comma y z in R. Maybe some x y z it will be true, but not true for all x y z. Is it okay? Is it okay? Is there any question? So therefore C option is not true always. C option is not true always. Then what about D? D is not metric. Why? D is not metric. I'm saying D is not metric. Why? Suppose D is a metric, we know that D of x comma y equal to 0 if and only if x equal to y. Suppose D function is metric, D of x comma y, whenever D of x comma y equal to 0, which implies x equal to y, right? Correct, right? But we already know, we have the example. The option A is false. This is not true. If D is a metric, this is true statement. This is not a true statement, therefore D is not a metric. So therefore D is not a metric. Did you getting my point? Suppose the D function is metric, this always satisfying this condition. We know initially, we know this is not true for all x and y. Initially we know this, the first option is not true for always. So therefore D is not a metric. So that is why I think that D option is true. So now the question, the answer is B comma D only. Is there any question, please? Is there any question? Can I move next question? Is there any question? Did you understand? தமிழ் அட்டென்ட் பண்றவங்க புரியலன்னா கொஞ்சம் மெசேஜ் டெக்ஸ்ட் பண்ணுங்க. எனக்கு கொஞ்சம் ஸ்டூடெண்ட்ஸ் தான் நார்த் சைடு அவுட் சைடு இருக்கும். But most of them students, maybe they are attending Tamil students. Just say yes or no. If you understand, just yes, you can reply. Hello.
Sir, there is a question that has been posted in the chat box. One of the participants is asking, is there any generalization for this type of concept?
Actually, there is no general concept for these things. They have to define just normally they have to define. Right now, this time the question they will be asking greatest integer. Maybe next time they will be asking smallest integer or whatever. Some increasing function maybe they can apply. My point of view, there is no general concept for these things.
Okay, sir. Okay.
My point of view, it could be maybe, but I didn't feel anything. But this is a simple ordinary we have to define. D of x comma y equal to greatest integer of modulus of x minus y, they are defined. Even though we can also define. For example, I can define. This is a way of asking question, that's all. Mod of e power x minus e power y. Whether they will be asking whether this is a metric, which of the following are true, whether this metric or D. Not necessarily e power x and y, just you can f of x minus f of y, they will be asking. Different kind of question we can ask. Mod of f of x minus f of y, where f is strictly increasing function, something they can write. This is a way of creating metric, but this function is not making metric. Maybe in future, this year or next year, coming session, they will be defined d of x comma y equal to mod of f of x minus f of y, where f is a strictly increasing function. Then they are defined, they will be asking with respect to this d is metric or satisfying this some conditions, or d is not a metric. With respect to this metric, r is complete, not complete. So this kind of question they will be asking. Maybe we are expecting. That's
Okay,
all.
sir. Thank you, sir. Thank you.
Okay, madam. Okay, madam. I'll go next question. Okay, this is the first day. I also didn't get any idea to do that. Not a problem. The teaching, because most probably we are teaching on always in Tamil. Only suddenly we can change in English. Little bit, it will be struggling for me. But I can manage. No problem for me. And the thing is that please, if you have any doubt, you can do the chat box. Madam, she will be informing me. This is a program for you only, for not for me. This program main purpose of to develop the faculties. Faculties are students. It will be helpful to for all going to write the CSIR exam. Not only CSIR, GATE or SET, whatever it is, competitive exams. Anyway, I'll write some other questions. Some interesting questions. Just another simple problem. Just I will do it. Just suppose that xn is a sequence of positive real numbers. Positive real numbers. Let they have to define yn equal to xn by 1 plus xn. Then which of the following are true? Option A, xn is convergent. Xn is convergent if yn is convergent. Option B, yn is convergent. Yn is convergent if xn is convergent. Option C, xn is bounded if yn is bounded. Option D. Option A is xn is convergent, yn is convergent. Yn is convergent, xn is convergent. If okay, yn is bounded, xn is bounded. Yn is bounded. Another one more. Yn is bounded if xn is bounded. Okay, please read the question paper 1 second. No need write. If you want, you can write or you can take a screenshot, whatever it may be. So just read the question paper. What is the question? Suppose that xn is a sequence of positive real numbers. You know, right? Positive real numbers means xn is always greater than or equal to 0. And given xn is a sequence of positive real numbers. Now they have to define a yn. Now they have to define a yn. How they are defining? Yn equal to xn by 1 plus xn. Now yn is also sequence, right? Yn is also sequence. The question is, they will be asking, then which are the following are true? Which are the following are true state? The first option, xn is convergent if yn is convergent. What is that meaning? Whenever yn is convergent, which implies xn is convergent. Suppose yn is convergent, which implies xn is convergent. The given. Second statement, yn is convergent if xn is convergent. What is that meaning? Whenever xn is convergent, which implies yn is convergent. What about third? If yn is bounded, which implies xn is bounded. Fourth one, xn is bounded, yn is bounded. Whenever xn bounded, which implies yn is bounded. What is your guessing, please? Please, you do the options. Just message me. Just you guess. Which are the following are true? Just guess. First you try. Just try. Just take a 30 second or 1 minute. Just take. AD, BC. Very good. Come on. Try. AD. Come on. D only. BD. Come on. Come on. Come on. Somebody is replying. I want to interact everyone. Come on. Whatever you know the answer, just to message. Whatever you know, whether it's true or false, just you have to guess and do it. And express very quickly. AC. Okay. AC. BD. Okay. Most of the answer A. AC and BD. AC and BD. Come on, very good. Good try. Come on, good try. D only. Good try. Come on. So the answer is only B and C only. So BC is very less people they are messaging me. But anyway, we have to check. So remaining things are false, but we will do it. Okay. So first option is false. Why is the first option is false? What is the first option? What is the meaning first option? Which implies whenever yn is convergent, which implies xn is convergent. What is that meaning? Yn is convergent, which implies xn is convergent. This is the meaning of the first statement. சரியா? P implies Q. P implies Q. Suppose you feel the first option is false. Yn convergent need not imply xn is convergent. That is a false statement. Suppose the statement is feeling false. Suppose you feel this is a false statement. You have to find xn. Suitably, you have to find xn. Yn is convergent, but xn is not convergent. So actually, P implies Q. What is this? Is a supposed true statement. What is the negation of the statement? P and negation of Q. This is a false statement. Now I have to choose xn equal to n, yn equal to yn. We already defined xn by 1 plus xn. This is equal to n by 1 plus n. This goes to 1. This implies yn is convergent. But what about xn? What about xn? Xn is not convergent. Xn is not convergent. What is that? This statement is not always true. This statement is not always true. True means sometimes it false. False means you have to give example. What is that example? I can choose xn equal to n. This is a positive real number. Why? The given statement xn is a positive real number. This is a sequence, just a natural number sequence. Xn equal to n. They'll start from 1, 2, 3, 4, and so on. This is a positive sequence that define the yn. Already yn they are defined like these things. Yn xn by 1 plus xn. So just a substitute and yn goes to 1. Yn convergent. But xn is not convergent. Therefore, this statement is not true always. Is it okay? The first option is not true always. Sometimes maybe. But true means always true. False means sometimes you can give an example. This is not valid always. Yn, whenever yn is convergent, need not imply xn is convergent. That is false. Okay, just I gave the example for xn equal to n and yn equal to xn by 1 plus xn. Are you okay? Can I move next? Next option. Is there any question? Is there any question? No? Okay. Okay, what about second option? Xn is convergent, which implies yn is convergent. They are asking question, the option B. Option B. Option B. What is that option B? Option B. What is that meaning of this? Xn convergent imply yn is convergent.
Sir,
Same
sorry
meaning.
to interrupt. Sir, there is a question from the participant who is asking that can we use the same example to show that C is not true?
Maybe. I'm not sure. We will check it. No problem.
Okay,
Maybe
thank
that example it will be working for all, and that I'm not sure, but maybe it will be using. We will do it slowly. We will do. Okay, madam. Yn equal to xn by 1 plus xn. This is a defined yn sequence. The second option means whenever xn convergent, which implies yn is convergent. Suppose if I have a sequence xn convergent, this implies yn is convergent. That will be a question. So we know that. What do we know? The yn already they defined xn by 1 plus xn. Xn is convergent, which means xn, all xn's are positive real numbers, and non-negative real numbers, strictly greater than 0. So this going to some L, that L also greater than or equal to 0, or greater than or equal to 0. Okay. So now 1 plus xn also greater than or equal to 1 plus L. Xn is positive and xn also goes to L, the limit also greater than or equal to 0. Xn's are positive, non-negative, the limit also non-negative. This is a theorem or some statement is there already in sequence. Xn is convergent, 1 plus xn also convergent. It converges to 1 plus L. L is positive and 1 plus this positive number also positive. So therefore, always greater than or equal to 0. So this implies L by 1 plus L. This is non-negative. Why non-negative? L is positive and 1 is positive and the sum also positive. It will be valid and yn converges to L by 1 plus L. So we are proved. What we are proved? We are assumed xn converges to L. This implies yn converges to L by 1 plus L. Are you okay? Are you okay? Therefore, B option is always true. Therefore, B option is always true. Whenever xn is convergent, which implies yn is also convergent. We are proved xn convergent, which implies yn also convergent. Therefore, B option always true. Is it okay? Are you okay? Can I move the C option? C option. Now, what is that C option? Okay, just I will rub it. What is that C option? Yn is bounded, which implies xn is bounded. Just I am writing different way. This they given this is the English meaning they are giving. Just I am writing our mathematical language. P implies Q statement, like this is the same meaning. Whenever yn is bounded, xn is bounded. So whenever yn is bounded, whenever yn is bounded, which implies xn is bounded. So I can choose xn equal to n and yn equal to, they defined, right, xn by 1 plus xn. This is equal to n by 1 plus n. The same example, it will be working. This goes to 1. So this convergent sequence, convergent, yn is convergent, which means bounded. Convergent implies always bounded, right? So therefore, clearly yn is another. Yn is bounded. But xn is not bounded. Xn is not bounded. So yn, whenever yn is bounded, not necessarily implies xn is bounded. So therefore, C option is not true always. I am sorry, here I will be put right. Not necessarily true. Yn is bounded, which implies xn is bounded. This is not true always, because I have an example. Xn and yn, I define this yn is n by 1 plus n. They will be converges to 1. We know that every convergent sequence is bounded, but therefore clearly yn is bounded, but xn is not bounded. So therefore this option is not true always. Okay, I'm very sorry. Initially I thought it will be correct, but when I'm doing the problem, it is not true. Okay, anyway, fine. What about the option D? What about option D? What is the meaning of option D? xn is bounded, given xn is bounded, option D, xn is bounded, which implies yn is bounded. Yn is bounded. What is your guessing? What is your guessing? You have to assume that xn is bounded, yn is bounded. How we have to prove it? How we are going to prove? Xn is positive. Xn is positive. Xn is positive. Therefore, xn is bounded means modulus of, just you have to think of a usual metric only. Modulus of xn less than or equal to some m for all n. For all n. This implies modulus of yn. We are going to check whether yn is bounded. Yn is bounded means, what is that meaning? Just write it here. Just write it and do it here. Yn equal to xn by 1 plus xn. Just to take modulus, this is less than or equal to xn by, xn is positive and 1 plus xn also positive, because xn given positive real number. So this modulus means just 1 plus xn only. This is equal to, and this is less than or equal to xn by xn. We'll be cancelling. This is bounded by 1 only. Clearly, yn is less than or equal to 1 always. Not necessarily less than or equal to 1, some 2 or 3, whatever it may be. But here it will be less than or equal to 1. Yn is bounded. But what is, whenever xn is bounded, which implies yn is bounded. Whenever xn positive and xn is bounded, which implies yn is positive and yn also bounded, because yn they define like this. So therefore option is B and D. B and D. For all done the option B and D, just you tick it and put right, very good for whatever. Okay. So the second question, the answer is B and D only. Is there any question? Is there any question, please? Are you okay?
Yes, sir.
Okay, madam. So can I move next question? First I will do this other problem. Some other CSIR problem, interesting and a problem. Let f going from R to R be continuous. This is a continuous, be continuous and 1 function. Then which of the following are true? Which of the following are true? F is on to B. F is either strictly decreasing or strictly increasing. C. There exists x in R such that f of x equal to 1. D option. F is unbounded. F is unbounded. Which are the following are true? Just to guess please. Last problem, most of the people they done very correctly. BD, somebody they send a message BD. What about this problem? You have any guess? You have any guess, please? Just read and whatever you have idea, just you guess it and do it. Do it the problem. Please, any guess? B only, okay? B, maybe. BD, B. B, okay. Just guess and do it. AD. Come on, very good try. Come on. BC, B. People are trying. BC. Okay. Good. Good try. First I read the problem, then I will solve the problems. Okay. So what is the given? Let f going from R to R be a continuous function. Given f is a function from R to R. It's a continuous function from R to R. And 1 continuous and 1 given hypothesis f is a continuous function from R to R and f is 1 continuous and 1 then which are the following are true? So f is continuous and 1 this is a P statement. The first option they are asking whenever f is continuous and 1 implies f is always onto, that is option A. Whenever f is continuous and 1 this is a P statement which implies f is onto, that is first option. The second option, f is continuous and 1 continuous 1 function always either strictly decreasing or strictly increasing, option B. F is continuous and f is 1 the continuous 1 function has this property. What is that property? There exists x in x, there exists x belongs R such that f of x equal to 1. The last continuous 1 function always unbounded, that is a question. Okay, option A is false, not always true. not always true. Why? You have to fill something, or you have an example. F is continuous and 1 but not necessarily onto. You have such an example, the option A is not always true. Okay, I can draw the graph in the board. This example, knowing most of the people, tan inverse of x, tan inverse of x. Just very bad drawing like this. This is a tan inverse x, tan inverse of x graph. This is 1 and continuous function. This is a continuous. There is no breaking. It's a continuous, and as well as this is a 1 So clearly we know this is a 1 function, or you can check the horizontal line strip. Wherever you can draw horizontal line, it will be intersect with only one time the graph. This is a clearly 1 continuous function, but is not an onto. The first option asking 1 continuous function always implies onto. Not necessarily onto. I have a continuous 1 function, but that is not necessarily onto. This is an example. This is an example, continuous and 1 but tan inverse of x is not onto. So therefore, this is not true always. We can draw a lot of functions. We can draw a lot of functions. So many more functions we can draw. It's a 1 continuous function like this. Not necessarily tan inverse of x. This is a one kind of functions, and lot of functions we can draw. 1 continuous, not necessarily onto. Okay, but anyway, this is an example. If false means we can give at least one example is enough. So therefore, this is not always true. Maybe sometimes it will be true, but true means always true. True means always we have to prove it. 1 and continuous implies always on to a question. Not necessarily. I have an example 1 and continuous, but this tan inverse of x is not on to. Not on to means you can take any element here more than pi by 2 or pi. There is no element whose image equal to pi. Therefore, tan inverse of x is not on to. Just take a pi in the codomain. There is no x whose output tan inverse of x equal to pi. Therefore, tan inverse of x is not onto. Okay, anyway, you know basic mathematics, there is no problem. What about now I am going to solve that option C and option B, then I will come finally option B. The question, the option C, whenever f is continuous 1 function always have this property. What is that property? There exists x in R such that f of x equal to 1. There exists an x in R such that f of x equal to 1. They ask a question. That is also false. False means you have to give a counter example. Continuous 1 function need not have this property. What is that property? Need not have this property means you have to give an example. Now I have to give an example. What is that? Just I can draw. Just I can draw some example. This is suppose you have to assume 1 and 2. Now the tan inverse of x I can translate like this. Like this is a function which is continuous and 1 of this interval 2 to some 4. Not necessarily tan. This is not a tan inverse of x. Like tan inverse of x, just I can translate it. Just you can write f of x is equal to 10 plus r tan inverse of x plus 10. You can write 10, but I here just a 2 unit I will be upper. Whatever it may be. This is an example. I am not very sure this is a tan inverse of x. Just some function like this is a very clearly and 1 and continuous, but there is no x. There is no x f of x equal to 1. Why? All output are more than 2. All output are more than 2. Here they will be asking f of x equal to 1. Such x exist or not? There exists x and r such that f of x equal to 1. There is no x. Because why? There is no x. Just I can go and see the x whose output is here. Just to go and see the x whose output is there. All the outputs are greater than 2. All outputs are strictly greater than 2. Okay. So therefore, this option is not true for all 1-1 continuous function. This is one of the 1-1 continuous function does not have the property C. Okay. So therefore, C is not always true. What about this? What about this? What is option D saying? What is the option D saying? F is continuous and 1-1 always implies F is unbounded. Unbounded? Not necessarily. I have an example. This is a 1-1 continuous function. This is bounded. Bounded by, so this range is lies between 2 to 4. The last option says that 1-1 continuous function always implies F is unbounded. This is not true always. Not true means we have to give it an example. What is that example? I draw this example. Or you can take a tan inverse of x also. Tan inverse of x also the same example. Tan inverse of x 1-1 and continuous but bounded. This says that 1-1 continuous function always unbounded. Option D says this is not true always. I have a 1-1 continuous function, but that is not unbounded. Okay, that will be bounded function only I have. That is called in a tan inverse of x. Or you can write tan inverse of x. Whatever, not only this function, lot of functions are there. Anyway, what about the C option? So option A false and C false and D false. The option B only true. Why B only true? This is a theorem and statement. I'm not going to prove it right now. They already most of the books it will be available. 1-1 continuous function either strictly increasing or strictly decreasing. 1-1 continuous function. 1-1 continuous function always strictly increasing or decreasing. Okay. Suppose the given question continuous is not available, then just let f be a function and 1-1. This implies what about all the options? Just to take a homework and do it. Here I removed continuity. Just a function is 1-1. 1-1 function implies all those things. What is your guess? Continuous 1-1 function implies always B option. There is a standard theorem and the standard theorem is there. That will be theorem. Now I am not going to prove it that theorem. The theorem says that 1-1 continuous function implies that either strictly increasing or decreasing. So that is why according to that theorem B is true. Now the question is, just I removed continuity. Just I removed continuity and f is just a function. Just f is a 1-1 function. 1-1 function implies is any options. That is for homework for you. Okay. Anyway, fine. Is there any question? Is there any question? Madam, is there any question asked people?
No, sir, not so far.
Okay. Anyway, fine. Next, we will do some other geometry kind of problems. Okay. So we will do it a very simple problem. Okay. So fourth one, let P of x be a polynomial function. Polynomial function in one variable. One variable of odd degree. Odd degree and G be a continuous. Oh, this is my short notes. Continuous function. Continuous function from R to R, then which of the following are true? Which of the following are true? Option A, there exists a point in R such that P of x naught equal to G of x naught. G is a polynomial. G is a polynomial function. Then there exists x naught in R such that P of x naught equal to G of x naught. C option. If G is bounded function, then there exists x naught in R such that P of x naught equal to G of x naught. This is a question December 2019. Option D. There is a unique point. There is a unique point x belongs to R such that P of x naught equal to G of x naught. Just read the question paper, please. Just read the question paper. Just read the question paper. Just try to understand what is given. Read the question paper and try to understand the concept and connect the logical argument, and which are the following are always true. Which are the following is always true means true the option you have tried to prove it. False means you have to give the example. Any answer, please? Any answer, please? ABC. ABC. Maybe, I am not sure. Next. Come on, reply, response. Sivaranjini, option C. Good. Next. Come on, response. Come on. Only few people are very responding. Very rare responding. Only few people are there frequently response. Other people, they are very silent. BC. BC. B only. Anyway, I'll read the question papers and I try to solve the problems. So what is the given solution? Given P of x is a polynomial function in one variable of odd degree. P of x is a polynomial, some a0, a1x, a2, x square, and so on. A 2n plus 1 or 2n minus 1. 2n minus 1, x power 2n. It's an odd degree polynomial. Degree of P of x equal to 2n minus 1. Next, given hypothesis, another hypothesis, G is a continuous function. So given hypothesis 1, hypothesis 2, G going from R be continuous. Two hypotheses, general hypothesis, two hypotheses, R2 are continuous function. What about option A? So there exists a x naught in R such that P of x naught equal to G of x naught. What is that meaning? So given any odd degree polynomial P of x, given any odd degree polynomial P of x, any continuous function G, always they have to meet some place. That is the meaning. There exists a point. They have both of them they have to intersect somewhere. The first option says like that. First option, what they said. So given any odd degree polynomial P of x and G is a continuous function, odd degree polynomial P of x and G is a continuous function, always they can meet somewhere. They can meet somewhere, which means P of x and G of x always they have to intersect. At least one time they have to intersect. That is a meaning. At least there exists means another. At least one time they have to intersect P of x and G of x. That is the meaning that P of x naught equal to G of x naught. Both of them they have the same output at least some point. At least one point. They said like that. First option. What about second option? Given already P of x odd degree polynomial and G is a continuous function. Now the second option says that G is a continuous polynomial and they gives very strong recommendation for that second option. G is continuous means right now here the very strong extra hypothesis. G is also polynomial. P already polynomial, G already polynomial. P on the odd degree polynomial and G is any polynomial. They always meet at least one time. Option B, explanation. Option B, meaning. What about C? P is odd degree polynomial. Given common hypothesis, P is odd degree polynomial. And G is continuous and given extra hypothesis. Third option, separate hypothesis. Continuous and bounded function has this property. What is that property? P is odd degree polynomial and G is a continuous bounded function. G is a continuous bounded function. They always meet at least one point. Option C, meaning. What about the D? What about D? Given any odd degree polynomial, G is any continuous function, always meet unique point. Unique point. They have to meet exactly one point always. P of x odd degree polynomial, G is a continuous function, always they can meet a unique point. So what is your guessing? Most of the people they said that A, B and B, C, R, B, D, whatever they replied. But still I am not say which is correct, which is wrong. Now we are trying to guess each one. Okay. So I am guessing option A is false. Option A is false. False means I have to give an example. I have to give an example. Okay. Now solution of A. A is a false statement. False statements means, but true means given any odd degree polynomial, any continuous function. Given any odd degree polynomial and G is any continuous function, always they have to meet at least one point. True means we have to prove. Suppose you feel the option A is false means suitably you have to choose some odd degree polynomial, some continuous function. They never meet. They never meet. Okay. Now I have to give an example. I can choose P of x equal to x. The identity function is a polynomial of degree 1. This is odd degree. And G of x is equal to x plus 1. This is a continuous function. Not necessarily polynomial. They said just a continuous. But I am choosing G also polynomial. G also polynomial and polynomial is also continuous function. So I choose only this function, G of x. Now, what is the graphical idea? So identity function, this is identity function. X plus 1, this is an x plus 1. This is your P of x. This is your G of x. This is an odd degree polynomial. This is a continuous function, but they never meet. but they never meet. So therefore, option A is not true always. Not true always. Are you okay? Option A is not always true. I have a odd degree polynomial and I have a continuous function g, but they never meet. Never meet. Therefore, this option is not always true. So you have to write this example. Not only this, you can write a lot of examples are there. Okay. Anyway, just I wrote simple example. Next, option B. If g is a polynomial, then has this property. Given P odd degree polynomial, G is continuous. Now the second hypothesis, extra hypothesis they are giving for G. G general hypothesis continuous. Now they have to including in B option continuous and that function should be polynomial. G when the continuous and G is a polynomial. P polynomial, odd degree polynomial, G any polynomial, they have to always intersect at least one point. The option B says that. I said the option B is not true always. Not true always means I have to give an odd degree polynomial P of x and I have to suitably find G of x polynomial function, but they never meet. The same example. Same example. Why the same example? The general hypothesis P of x odd degree polynomial. I have an odd degree polynomial and G of x is a polynomial. G of x is a polynomial. If this is odd degree polynomial, this is also polynomial, but they never meet. But they never meet. Therefore, this option is also not always true. Not always true. Actually, this option only for G continuous. The second option, they give some extra hypothesis. Not only continuous, it will be polynomial. Continuous and polynomial has always this property. Even though G polynomial, they don't have this property. So therefore, this option is not true always. So therefore, B also falls. The same example it will be working. Is it okay? Same example it will be working. So option A falls and B falls. What about G? G is bounded function. Then there exists x naught in R such that P of x naught equal to G of x naught. And another one more D option is there is a unique point. Always there exists always unique point P of x naught equal to G of x naught. The same example it will be working for D option also. Option B also same example. Option D also same example. Why? Yeah. P of x is odd degree polynomial and G is just a continuous function. But the option D says that always they have a unique fixed point. The unique point has this property, which means there P of x and G of x, they have to intersect exactly one time. Exactly one time. Whenever you have any odd degree polynomial and any continuous function, always has this property. They said option D. I am saying that I have a P of x odd degree polynomial and G is a continuous function. Don't have this property. So you don't have this property means you have to give an example. I have a polynomial P of x odd degree and G of x a continuous function, but they don't have this property. So therefore, this option is not always true. What is that example? P of x is a P of x equal just identity function. This is a 1 degree polynomial, first degree polynomial, and G of x a continuous function, but they never meet. So therefore, option D is not always true. Now option C. Suppose the option C is true, we have to prove. We have to prove. We have to prove. What we have to prove? Now the answer is C is. Suppose you feel C is correct, mean we need to prove, or just we need to justify whether it is possible or not. Okay, anyway, I try to explain. So just to take a result, any odd degree polynomial, okay. So I'll take a result, any odd degree polynomial of range is polar. That is a range of P of x equal to polar. which means odd degree polynomial is always onto function. How to prove? How to prove? So that will be, it will take time to prove it, but you can take a result. Any odd degree polynomial always whose range set is R, which means all odd degree polynomial is onto function. All odd degree polynomial is onto function. So, and also one more thing you also know, any odd degree polynomial has at least one real root, right? One real root, which means they have to cross at least one time in the x-axis. It will be going like these things. We don't, I'm not sure. All odd degree polynomials not like that things, but odd degree polynomials is going so like this. At least one time it will be crossing or this side, or it could be this side. We don't know, but that will be onto. It will be covering. So maybe 4, 5 times maybe intersect. We don't know. At least one time they have to intersect, which means they're crossing x-axis. Or you can take result any odd degree polynomial whose range set is R, and this says that odd degree polynomials are always onto function. That's all. Okay. Anyway, what about G? G will be given next hypothesis continuous. G is now bounded continuous function. Extra hypothesis. G is given general hypothesis continuous, and given another extra hypothesis bounded. Now bounded continuous function. Bounded continuous function means G is the range set somewhere. So bounded means you have to the range is lies like this. But G of x is less than or equal to some m. G is bounded and continuous function. So G is bounded continuous function. You can draw anywhere. At least it will be crossing at least one time. At least one time it will be one time crossing. Where it will be crossing? Just you draw the polynomial odd degree polynomial. It will onto, and G is a bounded function whose range is like it. G is bounded and continuous function. Now you have to draw the any graph within this bound. It will be crossing at least one time for this kind of polynomials. Or I have to give a hint. You have to prove it. I will give the hint. Use the intermediate value theorem or location of roots theorem. You can prove it. It will be very simple only. Now h of x they have to define like this: p of x minus g of. Given hypothesis G only bounded, yes, not necessarily bounded. Now this is now I have to define. So h of x is less than or equal to p of x minus m. Why? Why? Because g of x is bounded, that is less than or equal to some m. H of x is less than or equal to p of x minus times of m, and greater than or equal to minus m. Is it okay? Okay. And very large x, it will be positive. Very large x, this p of x goes to because p of x as p of x onto function, we can find an element in the codomain whose output more than m. So some x it will be positive and it will be negative, and h is a continuous function. H takes value. H is continuous. Y continuous. P of x continuous. G of x continuous. This difference continuous. H is continuous function. This continuous function takes some negative value and some positive value for some x. Therefore, by location of roots theorem, G of x at some point it will be 0. It will be crossing x-axis. Why? H of x is it take negative value as well as some positive values. H of x lies between some positive and a negative value. By location of roots theorem, it will be crossing at least one time the x-axis, at least one time. Just I call that point x naught. H of x naught equal to 0, which implies p of x naught minus g of x naught equal to 0. This implies p of x naught equal to g of x naught. Now what that says, this option C is always true. Odd degree polynomial and bounded continuous function, always they have to meet. at least one time. So therefore option C is right. Option C is always right. Okay, now maybe next time they will be asking question, P of X is a polynomial one variable of even degree. Of even degree. Now G is a continuous, or maybe take same hypothesis and instead of odd you can write even. Then which are the following are true? Just to take homework and do it. Which are the following are true? P of X is an odd degree polynomial, then option C only true. What about a P of X is an even degree? What about even degree? Just you note it and you try to solve. Try to solve. Okay? Is it okay? Just to try to solve. Can you find? I will move some other problem. Is there any question? Is there any question, please?
Sir, there is a question, sir.
Yes, please, madam.
Using odd degree polynomial has a real root. May I know what is the conclusion? This is the question posted, sir.
Again, please, again one more time you can ask, madam. I couldn't understand very clearly. Question. Odd degree, using odd degree polynomial?
Odd degree polynomial has a real root.
Yes.
And therefore, what is the conclusion? This is the question.
Where it will be using? Oh. So odd degree polynomial as at least one root means we are not using a root here. Just I am recalling or remembering. Odd degree polynomial as at least one root. Just I am recalling, remembering. I am not using anywhere this proof. Just we are using odd degree polynomial is onto function. Only we are using onto only. Just I am simply saying. Just I simply said that odd degree polynomial has at least one real root. Just I am recalling. I recalled, that's all. I am not using anywhere here. I am using only odd degree polynomial is onto. Using through onto, I proved something. That's all. Is it okay, madam?
Yes, sir. One more question, sir.
Okay, madam.
Please explain there is this means in option A and B once again.
Option A and B. Okay.
Yes, sir. A and B once again.
Okay. Actually, general given hypothesis P of X is a odd degree polynomial. Please watch. P of X is odd degree polynomial. Just I wrote it. Odd degree polynomial and G of X is any continuous function. This is a common hypothesis. P of X is an odd degree polynomial and G of X is a continuous function. That's all. The question, the first option they're asking, always P of X and G of X always at least one time they will be intersect. Always at least one time they will be intersect. The option A says that whenever you have P of X odd degree polynomial and G of X any continuous function, they always at least one time they have to intersect, which means always they have the common values at some point. At least one point whose output, both the outputs are same. They said like this. I am saying that this is not always true. Not always true means I am trying to give a counter example. I have some polynomial P of X odd degree, some continuous function, but they don't have any common point. P of X, just I take it X is a odd degree polynomial. False means we have to give at least one polynomial. True means you take any odd degree polynomial, we have to prove it. Okay. P of X is an odd degree polynomial and just I am taking G of X equal to X plus 1. This is a continuous function. This is an odd degree polynomial, but they don't have a common point. Why they don't have a common point? And P of X graph, you know, everyone know. P of X is equal to X. What about G of X? G of X graph also you know everyone. This is a G of X. One unit it will be upper. X plus 1. This is a G of X. But P of X odd degree polynomial, G of X continuous function, but they don't have any common point. It will be like how the railway track is going like that. The same thing the graph is going. They never meet. They never meet. So therefore, this option is not always true. Therefore, this option is not always true. Sometimes it will be true, but that will be not, we are not taken. True means always true. Always true in the sense, you take any odd degree polynomial, any continuous function, always they have to meet. I said that this is not true always, which means I have an example odd degree polynomial and a continuous function, they never meet. Therefore, this is not true always. Okay, the same example it will be working for B option also. Now the B option extra hypothesis they are given, continuous and polynomial. P of x is a general, it's an odd degree polynomial. The second, G general hypothesis continuous, then the special case continuous polynomial, continuous as well as G should be continuous. G should be polynomial, continuous, G polynomial. Now G has two property right now, extra continuous and G is also polynomial. Now the both the things having common point, at least one common point, they said the option B. G is a continuous polynomial, then they have the common point. I am saying that no, same example it will be working. P of x is a general hypothesis, odd degree polynomial. Yeah, is odd degree polynomial. G of x is continuous as well as G of x a polynomial, but they don't have common point. So therefore, option B is also not always true. Not always true. Please, is there any question?
No, sir.
Is it okay?
Fine, sir.
Okay, madam. So can I move another problem?
Sure, sir.
Okay, madam. Is there any difficulty, madam? Students, they will be saying something. The language is not understand something there.
No, sir. Nothing of that sort. Somebody is asking to explain option C just once.
Okay. The option C is it will be true statement. So just I am saying they have to try to understand and then try to prove it. So you have to take P of x odd degree polynomial. Odd degree polynomial is onto function. All odd degree polynomials is onto functions. And G of x is a bounded continuous function. Bounded continuous function in the sense. Okay, first just geometrically just try to understand. G is a continuous and the extra hypothesis is bounded. That will be you have to join continuous and bounded. Bounded continuous function. G bounded continuous function means G range set of G is somewhere. It will be continuous function like this. Just I am justifying, that's all. So all the range set it will be lies within these things. Okay. Now P of x is odd degree polynomial. Odd degree polynomial means odd degree polynomial they have to vanish at least one real root. Somewhere it will be vanishing. I don't know. Just I am roughly just saying. Somewhere it will be vanishing. And P of x is onto function. So I gave that result. Any odd degree polynomial is onto function. Just to take a result. And polynomial is also continuous. And somewhere it will be going like this. So they have to meet right now like this. So that is what I said that h of x I defined P of x minus G of x. And using location of roots theorem and some x, this is bounded. G of x is bounded. Up P of x, this is less than or equal to P of x minus M. And some x, it will be more than some x, it takes P of x more than some M. So therefore, this is somewhere positive. And this is also going negative, very large like x. We don't know. Somewhere it will be taking very negative values, and to take this value, the both of them, it will be negative, which means some point it will be negative. That will be very sure. Some point it will be positive, some point it will be negative. So in between G of x, G of x take somewhere positive, somewhere negative, and G, not G, H is some point positive, some point negative, and G is a continuous function. Therefore, by location of roots theorem, G vanish at least some point. H of x, at some point it will be positive. Same H of x, some point it will be negative. By location of roots theorem, says that H is a continuous function. Statement of location of roots theorem. Given f is continuous function, some point positive, some point negative, it takes at least one root lies between this positive point and negative point. For example, f is a function, some point it will be positive, some point it will be negative. So this is a continuous function, at least one time it will be crossing. This is a root. The similar thing, h some point positive, some point negative. H is continuous. Y continuous, P of x continuous, G of x continuous, difference continuous. H is continuous function. A continuous function, some point positive, some point it will be negative. Therefore, H vanish some point. Therefore, H vanishing some point. Just I call x naught. This implies there exists x naught in R such that H of x naught equal to 0. H of x naught equal to 0 means H of x naught equal to 0 means this implies P of x naught. Go and substitute. H of x naught equal to P of x naught minus G of x naught. G of x naught equal to 0. This implies P of x naught equal to G of x naught. So therefore, option C is always true. I am not written very rigorous proof. Just I am said the way of writing of the proof. How the proof is going like that. Is it okay, madam?
Yes, sir.
Okay. I can move some other problem.
Yes, sir.
Okay, madam. So most probably people they thought like that analysis a little bit difficult, but when we making more practice it will be easy only. In the exam point of view, analysis save the times. Okay, anyway, I will do another simple problem. Okay, another one more simple problem, just I will do it. Okay. Let f of x be a real polynomial of degree 4. Suppose f of minus 1 equal to 0, f of 0 equal to 0, f of 1 equal to 1, and f prime of 0 equal to 0. Derivative. Then which of the following are true? Option A. There exists a alpha in minus 1 comma plus 1 such that f triple prime of alpha greater than or equal to 3. B option. F triple prime of alpha greater than or equal to 3 for every alpha belongs to minus 1 to plus 1. Option C. 0 less than f triple prime of 0 less than or equal to 2. Option D. F triple prime of 0 always greater than or equal to 3. Just read it and do the problem. Please read. Please read. What is the given? F of x be a real polynomial of degree 4. Real polynomial of degree 4. F of x of this form. A naught plus just a given, whatever given, just write it. Then you get some idea. A to x square, a cube x cube, a power 4 into x power 4th degree polynomial. Okay. Next, what is a given hypothesis? Just a given f of x is a polynomial of degree 4, fourth degree polynomial, and that fourth degree polynomial has this property. What is that property? What is the property? F of minus 1 equal to 0, f of 0 equal to 0, f of 1 equal to 1, f prime of 0 equal to 0. F of 1 equal to 1 or f prime? F of 1 also. Maybe. Just to change the question, maybe I were made forget, I don't know, it will be 0 only I putting. But anyway, this question I am answering. Anyway, fine. So what is that property? Fourth degree polynomial has this property. F of minus 1 it will be take 0, minus 1 it takes 0, 0, 0, 1 also it takes 0, and the derivative also 0. Okay. So how the f of x look like? How the f of x look like? 0 2 times it will be coming, which means 0 is a root of the fourth degree polynomial. 0 is a root of the polynomial. 0 root and derivative also 0. It comes derivative also root. Just 0 is a root of the f and 0 also root of the f prime, which means x square. The polynomial should be x square into minus 1 also root of x minus 1 plus 1 also root of x plus 1. This is your polynomial. This is your polynomial. So all problems are, this is CSIR problem. Every problem is a CSIR, but I didn't forget that here. Okay, given support the degree polynomial, given information, from that information, just I wrote it that polynomial explicitly. F of x equal to x square into x minus 1 into x plus 1. Okay, now you should take the derivative. F of x is equal to x square into a plus b into a minus b. A square minus b square, which means x square minus 1. This implies x power 4 and minus x square. This is your f of x explicitly. Now just to take derivative and check all the values. First, f prime of x 4 times of x cube minus 2x. F double prime of x equal to 12x square minus 2. F triple prime of x equal to 24x, that's all. This is f triple prime of x. Now what is the question? So this fourth degree polynomial has this property which implies there exists alpha in. The first option says that fourth degree polynomial always has this property. So our third derivative of x equal to 24x, 24 into x. Okay. This says that in between minus 1 to plus 1, there exists some alpha minus 1 to plus 1. There exists some alpha lies between minus 1 to plus 1 such that f triple prime of alpha greater than or equal to 3. F triple prime of alpha greater than or equal to 3. Okay. So what is our alpha? Just this says there exists some alpha. So now I have to choose alpha. Alpha belongs to minus 1 to plus 1. Na? Just I can choose alpha equal to half, then just I can apply. F triple prime of alpha equal to 24 into half. This is equal to 12 greater than or equal to 3. So always I can choose. Always exist. Just you need at least one alpha you can show. That is enough. Not only 1 by 4, 1 by 2, you can take 1 by 4 also, 3 by 4, you can take any number. Not any number, suitably you can choose. We can choose the element alpha lies between -1 to +1 and f triple prime of that alpha greater than or equal to 3. This is always possible. So therefore option A is true. What about option B? Option B says that f triple prime of alpha always greater than or equal to 3 for every alpha. But that is not true. For every alpha means this is not true. When alpha equal to -1 by 2, f triple prime of alpha equal to -12, which is less than 3.
Sorry to
But
interrupt, sir. Sorry,
yes,
sir.
madam.
There is a question from the participant who is asking what will happen if we take alpha 0?
Oh, okay, madam. See, existence means not necessarily taking showing all well. False means okay. Anyway, these people they couldn't understand. The option says that there exists a alpha lies between -1 to +1 whose triple prime of alpha greater than or equal to 3, which means such alpha exists or not. Exist means we can give at least one alpha. Just I was chosen alpha equal to 1 by 2. Suppose you are taking alpha equal to 0 means what is that 0? 0 does not have this property. Is it okay? Suppose if you are taking alpha equal to 0, 0 does not have this property. But here they said that you can able to find an alpha, one alpha -1 to +1 whose f triple prime of alpha greater than or equal to 3 means 3 means existency. We have to show at least one. But alpha, when you're taking alpha equal to 0, it does not satisfy that property. Which property? This property. They're asking existency. When you're choosing alpha equal to 0, 0 does not satisfy. I don't want such alpha. I want me to find an alpha whose f triple prime of alpha greater than or equal to 3. So I have an alpha equal to 1 by 2 as this property. There exists at least one alpha, you can always find out. 0 does not work. -1 by 2 does not work. -3 by 4 does not work. Okay, not all alpha working. Some alpha, they asking you have to find some alpha as this property. What is your answer? Yes, I have an alpha equal to 1 by 2 as this property. Therefore, this option is true. I can able to find it. There exists means you can able to find it. You can able to find it. Yes, I can able to find it. Alpha equal to 1 by 2 as this property. That's all. Is it okay?
Okay, sir. Thank you, sir.
Okay, madam. What about B option? F triple prime of alpha greater than or equal to 3 for every alpha. This is not true. For every alpha, that is the meaning. That this is a very important for every. This says that all alpha, you take any alpha -1 to +1. For every means you take any element -1 to +1 whose f triple prime of alpha greater than or equal to 3. I said that it will be false. Why it is false means I have some alpha whose f triple prime of alpha less than 3. This is not true all alpha. I have some alpha. B means true means you have to take any alpha -1 to +1. Just to take alpha -1 to +1, you substitute always greater than or equal to 3. Then this option is true. False means you have to find some alpha. You have to find. So B option I was felt it will be false. False means I can able to choose not working for all alpha. I have some alpha. I have alpha equal to -1 by 2. When I'm taking alpha equal to -1 by 2, f triple prime of alpha which is less than 3. Strictly less than 3. Therefore, this option is not true. Not all alpha value greater than or equal to 3. Some alpha value less than or equal to 3. Why? Because I have the function f triple prime of x. I have very clearly this here. So therefore, this is not true for all alpha. Therefore, this option is always not always true. not working for all alpha. So therefore this is false. What about this? We know f triple prime of 0 and very clearly 0. So here this option says that f triple prime of 0 greater than 0 and less than what? 2. But f triple prime of 0 exactly 0. 0 strictly greater than 0? No. F triple prime of 0 is 0. Correct. F triple prime 0, 24 into 0 is 0. 0 strictly greater than 0? No. So this is not true. What about this? F triple prime of 0 greater than or equal to 3. F triple prime of 0 is in 0. 0 not greater than or equal to 3. F triple prime of 0 not greater than or equal to 3. So therefore this is also not true. The only option is A. Is there any question? Is there any question, please?
Nothing, sir.
Okay, madam. Okay, can I move another problem? Another simple problem. Okay, I'll do some other problem, easy geometric problem. Okay, so you won't need some problem. Seventh problem, I think so. I don't know. Okay, n be a fixed natural number. It's a simple problem. Natural number, fixed natural number. Then the series. Then the series summation minus 1 whole for m by m. M greater than or equal to n is option A. Absolutely convergent. Option B, divergent. Option C, absolutely convergent if n strictly greater than 100. D option, convergent. So another one more problem. Let A and B a bounded sequence of real numbers. Sequence of real numbers. Then option A, every subsequence of an is convergent. Every subsequence of an is convergent. B, there is exactly, very quickly I will try to explain, exactly one subsequence of an which is convergent. Option C, there are infinitely many subsequence of an which are convergent. Option D. There is a subsequence of an which is convergent. It's a very simple problem. Okay, given just to see the option, let n be a fixed natural number. It's a fixed natural. It could be 1 or 2, 5, whatever it may be. We know this, right? Already we know. This is an alternating sequence. So already alternating series. Alternating series monotonically decreasing, and you know Leibniz test for a series. First it will be alternating sequence and monotonically decreasing and converges to zero by Leibniz rules by Leibniz test. This series is convergent, right? This is convergent. Clearly everyone know this is a absolute, this is a convergent by Leibniz test. Leibniz rule. Leibniz tests are Leibniz rule. According to Leibniz tests, this series is convergent. Here they will be asking after some n, we don't know. Maybe what is this meaning? M may be greater than or equal to 1 or 2. Some natural number fixed, that is some n not fixed. After that, minus 1 power m by m. This is a according to Leibniz test, this alternating series is convergent. Alternating series is convergent, which means after some n naught. Here n 1 to infinity, we know this is a general. It's a very large series, it will be convergent. So after sometimes it could be n naught 1 or 2. N naught equal to 1, the same thing happens. N naught equal to 2 or 3, whatever it may be, this series is convergent. So what kind of, this is absolutely convergent. Absolutely convergence means when you put modulus, it will be convergent. So when we put modulus, just 1 by m. When you take modulus of minus 1 whole power m by modulus m positive, just you take modulus m means just m. This become m greater than or equal to n naught, just 1 by m. This is divergent. So this is not absolutely convergent. Absolutely convergence means when I given the series is absolutely convergent, they will be asking just to put modulus. If you put modulus, after that it will be convergent, then we say that absolutely convergent. Okay. So this given series, if I put modulus, just it will be 1 by m, where m greater than or equal to n. So this will be very clearly divergent. So therefore this is not absolutely convergent. So therefore this option is false. First option. They will be asking divergent. No, this is a convergent by Leibniz test. So therefore B also false. What about C? Absolutely convergent if n greater than 100. No. They say that n it will be more than 100. It will be absolutely convergent in the sense it will be 1 by 100 plus 1 by 101 plus 1 by 103 and so on. This is not absolutely convergent. So therefore this is not true. If they say that n more than 100, more greater than 100, which means 101 or 102, 103, whatever it. The option C says that when take n strictly greater than 100, the series becomes absolutely convergent. No. Why? When you take modulus, just it will be 1 by 101, 1 by 102, and so on something. This is not convergent. You can take any test, logarithm test, whatever the test you can use it. It will not convergent. Okay. So therefore, absolutely convergent if n greater than 100. This is also false. Not true always. So not true. So only option is D is true. Why? By Leibniz test. According to Leibniz rules, they says that alternating series and monotonically decreasing. According to that test, the series is convergent. Just a convergent. It's not absolutely convergent. Just a convergent. So therefore, option D is true. What about this? Just a few minutes are there. Is there any question? Only hint, Leibniz test. Only hint, Leibniz test. Is there any question? No, right? Okay. Okay. Now see the question, the second question. This last question given an is a bounded sequence of real number. An is a bounded sequence of real number. So therefore an is bounded by some n. Every subsequence of an is convergent? No. Why? Why? So by Bolzano-Weierstrass theorem says that every bounded sequence has a convergent subsequence. Bolzano's theorem gives guarantee that you have a bounded sequence as a convergent subsequence. As means at least it has one convergent subsequence. So according to Bolzano-Weierstrass theorem, option D is true. So given an is a bounded sequence, according to Bolzano-Weierstrass theorem, every bounded sequence has at least one convergent subsequence. That will be statement of Bolzano-Weierstrass theorem. According to Bolzano-Weierstrass theorem, option D is right. There is a subsequence of A which is convergent. This is always true statement. Okay. Okay, fine. Option D is true. What about remaining? Every subsequence of an is convergent. Every subsequence of an is convergent. Second, there is exactly one subsequence of an which is convergent. No. No. There are infinitely many subsequences of an which is convergent. Yes. How? Just I give just 2 minutes are there. From the 2 minutes I will explain. That the option B is false. I will give the example. There is exactly one subsequence of an which is convergent. An equal to -1 whole power n. So a2n minus 1 always odd number -1. a2n always +1. This is an odd subsequence. This is an even subsequence. Option B says there is exactly one subsequence of an which is convergent. I have a bounded sequence. I have a bounded sequence which has a two convergent subsequence. Two convergent subsequence. So therefore, the option B says that whenever you have a bounded sequence, always has exactly one convergent subsequence. That is a false because I have an counter example. Because I have an counter example -1 whole power n and even subsequence 1 1 1 it will be convergent. Odd subsequence -1 1 1. Is it okay? So therefore, option B is not always true. That is a counter example here. Okay. Another. So what about there are infinitely many subsequences of an which are convergent. Suppose how this will be true statement. How we can make a true statement? So Bolzano-Weierstrass theorem says that every bounded sequence has a convergent subsequence. Just that sequence I called this is a convergent subsequence by according to Bolzano-Weierstrass theorem. Now I have to make this is a convergent subsequence. Now I have to make a lot of convergent subsequence for this subsequence. Did you get my point? So according to Bolzano-Weierstrass theorem says that n is a bounded and the bounded sequence has a convergent subsequence. Just I call it A and K is a convergent subsequence. This is a convergent subsequence. This is a one of the subsequence. From this sequence, I can find lot of infinitely many subsequence of this sequence converges to same number. Just I call the infinitely many A N K1. This is one of the subsequence of this, and this is a subsequence of A N. Now this is a subsequence of A N like that. A N K some 2 another subsequence of this sequence, and A N K3 this is another subsequence. I can make a lot of convergent subsequence of this A and K, and A and K is a subsequence of A n. Therefore, A n K1, A n K2, A n K3, and so on. I can make infinitely many subsequence of this. Therefore, we have to always make infinitely many subsequence A n which are convergent. Okay. So every subsequence of A n is convergent. Not necessarily, right? Why? I can choose, I can define an equal to minus 1 whole power n when n is a prime. Otherwise 0. So when n is a prime, always it will be not a prime number. So I can make some other number. Just wait a minute. P is a prime. Prime is 0. Otherwise this will be. It's a prime number. So n is a prime. I can take 0. It's not a prime, minus 1 whole power n. So not a prime means some odd numbers are there, some even numbers are there. So it will be minus 1, somewhere plus 1, somewhere minus 1, again somewhere plus 1. This is a bounded sequence, but this is a subsequence. Subsequence means an k, where nk is not a prime. This is a subsequence. That subsequence minus 1 whole power. This is not convergent. So therefore, this option is not always true. So I have an example, counter example. It's a bounded sequence which is not convergent. Every subsequence is not convergent. Okay, you have any doubt? I think my time is run out. Is there any doubt? Please, is there any question?
No, sir.
Okay, can I close the session, madam?
Yes, sir. Yes, sir.
Okay, anyway, I have to wait. If you have any doubt, you can ask me, I will tell.
Sure,
The option
sure.
is somebody is there are infinitely many subsequences of n which are convergent means you have according to Bolzano-Weierstrass theorem, option D is true, which means an is they have some convergent subsequence. From that convergent subsequence, we can create a lot of convergent subsequence of this subsequence. So this is a subsequence of this, and this is a subsequence of this. Therefore, this is a subsequence of this. This is a way to create. Maybe next class I will tell you. Don't worry about examples. Somebody they will be asking doubt. I think they have time run out. Otherwise, I will explain. Is it okay, madam?
Okay, sir. Thank you, sir. Thank you.
Okay.
1 second.
Okay, madam.
Sir, suppose seventh question, I think the question is erased. Sir, if you permit, I'll give you your mail ID so that the participants can directly contact you, or shall I give the WhatsApp number?
WhatsApp number, madam. You can give the WhatsApp number. They have sent that whatever the doubt, then I will explain.
Sure, sir. Sure. Okay. Thank you so much.
Anyway,
sir.
thank you.
Thank you so much, sir, for the clear and detailed explanation. We have learned how to solve problems and gained a complete understanding of whatever has been taught today. We sincerely thank you for sharing your knowledge with us, sir. Hope today's session would have helped all the participants in acquiring new information. Keep practicing and be ready for tomorrow's session, sharp 3 p.m. I request the participants to kindly fill in the feedback form using the link posted in the chat box. Thank you all and have a nice day. Thank you so much, sir. Thank you, sir.
Okay, madam. Thank you. Bye. Take care. Read well the problem and try to solve individually. If you have any doubt tomorrow, you can ask. I will explain. Okay. Thank you. Anyway, bye. Take care.
Thank you, sir.